All right, today we are cracking open a 65 million year old cold case. We're going on a hunt for the killer behind one of the biggest mass extinctions our planet has ever seen. This is a real-life scientific detective story, and we're going to follow the clues step by step. You know, it's the question everybody asks, and for so long, it had scientists totally stumped. But then, back in 1980, a team of researchers published this paper that laid out direct physical evidence for a culprit that was, and I mean this quite literally, out of this world. The crime scene wasn't a room. It was the entire planet. And the list of victims? It was just staggering. We always talk about the dinosaurs, right? But they were not alone. You had marine reptiles, flying reptiles, these creatures called ammonites, and even the tiny microscopic plankton that were the absolute base of the ocean's food chain. Poof, all gone. All told, about half of all living genera at the time were just wiped out. And for the longest time, the investigators, the paleontologists, they had no murder weapon. They could see the aftermath in the fossil record, this sudden, shocking disappearance of species everywhere, but there was no physical clue, nothing left at the scene that could point a finger and say, that's what did it. So, with no hard evidence to go on, scientists basically rounded up a list of the usual suspects. You know, maybe it was a slow, gradual climate change. Or what about a blast of radiation from a star exploding nearby, a supernova? Some even thought maybe a reversal of Earth's magnetic field was to blame. They were all interesting ideas, but every single one was missing that one crucial piece, a smoking gun. And then, everything changed. The big break in the case came from the most unlikely of places, this thin, 1 centimeter thick layer of clay sandwiched between layers of limestone in a gorge in Italy. This little, unassuming layer of dirt marked the exact boundary in time between the age of dinosaurs and the age of mammals that followed. Inside this specific layer of clay, a team led by Luis and Walter Alvarez decided to look for an element called iridium. Now, why iridium? Well, it's incredibly rare here on Earth's surface. Most of it sank down to the planet's core ages ago. But it's really common in things like asteroids and meteorites. So, in essence, it's a fingerprint for stuff that comes from space. And just look at what they found. On the left, you see the normal, super low levels of iridium in the older Cretaceous rock. Same thing on the right, in the younger rock that came after. But right there in the middle, in that thin boundary layer that marks the extinction, the iridium level shot up by a factor of 30. This was it. This was the first solid piece of physical evidence. The murder weapon was finally starting to take shape. And get this, it wasn't just some weird local thing in Italy. Nope. Soon, scientists all over the globe were checking this same boundary layer, and they found the exact same dramatic spike in Denmark, in New Zealand, even in cores drilled from the deep ocean floor. Whatever did this, it was a truly global event. So, this discovery really narrowed the search. The clue was pointing up to space. It had to be an extraterrestrial source, but what kind? That old supernova theory was still on the table, but now, for the very first time, they could actually test it against the physical evidence they held in their hands. Okay, so this is where the investigation gets really good. It's time to follow the evidence and test the hypotheses. The team had their prime suspect, that nearby supernova, and they knew exactly what kind of forensic evidence it should have left behind. You see, the team knew that a supernova would leave behind two very specific chemical signatures. First, it would create a really specific radioactive isotope, plutonium-244. And second, the iridium itself would have a unique isotopic fingerprint, basically a different atomic flavor that's totally different from the iridium we find in our own solar system. The test was simple, really. Just check the clay for those two things. So they went back to that boundary clay, and they searched for that specific plutonium isotope. And they found absolutely nothing. Not a trace. Zilch. The first critical piece of evidence that had to be there just wasn't. The second test, it was even more of a slam dunk. They measured the iridium's isotopic fingerprint with incredible precision. And you know what? It wasn't the weird, exotic kind a supernova would make. It was a perfect match for the kind of iridium you find in meteorites from right here in our own solar system. The fingerprint was local. So, with 2 failed tests, the verdict was crystal clear. The supernova hypothesis, which had been a leading contender for years, was officially ruled out. The evidence just didn't fit, and that cleared the way for a brand new theory, one that perfectly explained all the clues they'd found. So, with the supernova idea officially off the table, the Alvarez team proposed a new culprit, a massive asteroid impact. The iridium didn't come from some distant exploding star. It came from a giant rock that had been orbiting right here in our own cosmic backyard. But hold on, how could a single asteroid impact cause a global extinction? Well, it wasn't the initial blast. The theory was that the impact vaporized the asteroid and blasted tons and tons of Earth's crust into the atmosphere, creating this colossal cloud of dust that reached the stratosphere. This cloud would have then spread around the entire planet, blocking out the sun for years. With no sunlight, plants die, photosynthesis stops, and the planet's food chains just collapse from the bottom up, a global blackout. Now, a great scientific theory makes predictions you can test, and this one made a really interesting one. It said that if the boundary clay was fallout from this global dust cloud, its chemical recipes should be totally different from the normal everyday clay found in the rocks around it. And when they checked, it was. Another piece of the puzzle just snapped right into place. This, of course, led to the next big question. Okay, so an asteroid was the culprit, but just how big of an asteroid are we talking about here? Could they actually use the evidence they had to figure out the size of this planetary killer? The answer they came up with was just astonishingly precise. Based on the total amount of that space dust, that iridium, found all over the world, they calculated that the asteroid had to be about 10 kilometers wide, give or take 4. We're talking about an object the size of a mountain slamming into the Earth. And this, for me, is the most amazing part of the whole story. They didn't just use one calculation. They came at the problem from 4 completely different directions. They calculated the size based on the iridium, on how often we expect big asteroids to hit, on the total mass of the clay layer itself, and even by looking at data from the famous Krakatoa volcanic eruption. And all 4 independent methods gave them the same answer, around 10 kilometers. That's how you build a rock-solid case. And the theory also explained the pattern of death perfectly. This global blackout would have hit the big, active animals the hardest. Just as paleontologist D.A. Russell pointed out, it seems no land animal heavier than about 55 pounds made it through. But the smaller critters, the ones who could burrow or scavenge or hibernate, they had a much better shot. So with all this evidence piling up, the case was pretty much closed. A consensus began to form around the impact hypothesis. But solving this one mystery did so much more than just explain why the dinosaurs disappeared. It fundamentally changed how we look at the entire history of life on this planet. For more than a century, the main idea was that big evolutionary changes happen slowly, gradually, over immense stretches of time. The Alvarez hypothesis proved that's not the whole story. It showed that history can turn on a dime, that it can be punctuated by these sudden, violent, catastrophic events from space that completely reset the course of evolution. Think about it. Without this impact, the dinosaurs might very well still be here, and we almost certainly would not. And that leaves us with one final, fascinating question. The extinction that killed the dinosaurs was just one of at least 5 great mass extinctions in Earth's history. So if an impact was the culprit for this one, could impacts be responsible for the others too? Well, that's a whole new mystery, and the investigation continues.